So, do you know what I have? A soccer ball! So, you might be asking, what does soccer ball have to deal with? Rotational motion. So if you see, it rotates. It also think of it as a globe. It rotates around the sun. Come on, around the sun. Around. And then it also spin around. It also spins around. Anytime you spin it. Anytime you spin it. Anytime you move it, it's rotating because it's round. It's a sphere. And then what's a sphere made of? A circle. And many circles. Many circles. And then what do circles rotating? What do circles have to deal with? Rotation. Circumference. You want to know the circumference? We're gonna tell you the formula of rotational motion, and that would be circumference times the number of laps. There you go. Simple physics, guys. Come on. Come on now, y'all can do this. You can do it. So we're gonna show you how this works. We're gonna show you a couple ways. So you can either spin it, okay? Spin it. Or Sade can kick the ball and you'll see it. Right here. You guys see it rotating? It's rotating. And it comes to an end when it hits another, well, not really stop. But it slows down. You saw how it slowed down when it hit the wall and it hit the trash can, and now it stopped. So you saw how it was rolling when I was there. Well, that's not the really scientific word for rolling. It was making a couple revolutions, revolutions. It was rotating, like rotational motion. The wheels on the bus go round and round type rotating, right? Exactly. And basically, and then you saw when it stopped when it hit the wall, because a force was applied to it. So in this case, the force was the wall and the trash can. And the force that applied it to begin in motion was my foot. The force. And the one before that, when we had spinned it, the force was my hand when I spinned. And the force to stop it was when it fell, because I did not balance it. So she didn't balance it. Okay. And see, the force it did not stay on my finger. Well, applied to stop it. Gravity has a good part to play with this too, because see, gravity is not going to keep it up. It brings it down. It brings it down. Bring down like that, because if there was no gravity, we'll be floating in the air, and we wouldn't. And then fun facts about soccer. So, do you know when it was invented, Sade? December 8th, 1863. Oh, y'all. Birthday month. Y'all. And then, did you know that 250 million players play over 200 countries? Interesting facts indeed. Wow, yowzer. Did you know the U.S. women's team has the most Olympic wins? Are you serious? And they doubted us on that, Monica. Ready? Come on. Go. Oh, I can't. This is why she's not on the Olympics, but I am. I'm going to show you guys rotational motion in even see her? The air. Can you guys see me? Rotational motion in the air. You guys ready? Fudge. Ready? Rotational motion in the air. Yowzer. You see it there? Right there, it's rotating. Wait till the applied force comes. And it stopped. Here you go. Rotational motion applies to many things, not just soccer, including the spinner. For instance, to find the distance of the revolutions in the spinner, you simply measure the diameter, which happens to be 10 inches. Then you divide that by 2, and that would be 0.5. The formula to find the distance for the revolutions would be circumference times the number of laps. The circumference is 3.14 times 0.5, which equals 1.57. You spin it around once, and the distance would be 1.57. You spin it around 5 times, 1, 2, 3, 4, 5, and the distance would be 7.85. Keep spinning. rotating like the sun around the world. And these petals off this dandelion. Brought to you by Sade Alvarez Gibson. See you later. Guys, you know, physics is cool. Brought to you by Manca Calvente. So you know, this is my part and I'm done. So I'm gonna just rotate away. And my force applied to stop is the steps. Special for you guys. Ready? Oh, soccer ball! In Latin American countries, they call it football. And so, bet you get to the soccer ball! Okay, let me see how high it is.